Just-in-time and lean inventory systems. Warehouse management and optimization. Warehousing, distribution, and last-mile delivery challenges. Logistics and distribution. Sustainable inventory practices. Just-in-time and lean inventory systems. Moving away from traditional buffer-heavy systems, JIT and Lean aim to streamline processes, minimize waste, and enhance responsiveness to customer demand. Purpose and objective. The primary purpose of just-in-time and lean inventory systems is to optimize operational efficiency and minimize waste by holding only the necessary inventory at each stage of the value stream. Just-in-time and lean inventory systems. The key objectives include reducing inventory costs, improving quality, shortening lead times, increasing efficiency, enhancing flexibility, promoting continuous improvement, Kaizen. The process. The implementation of JIT and Lean inventory systems involves a fundamental shift from the traditional push system, where materials are pushed through the production process based on forecasts, to a pull system driven by actual customer demand. The typical process flow encompasses several key elements. 1. Demand-driven production. Production is initiated only when a customer order is received or signals from downstream processes indicate a need for more materials. This pull mechanism ensures that resources are not used to produce items that are not yet required. 2. Minimized inventory levels. Inventory is kept to the absolute minimum required to maintain a smooth production flow. 3. Streamlined flow. Efforts are focused on creating a continuous and uninterrupted flow of materials and information throughout the value stream. It involves optimizing layout, reducing bottlenecks, and minimizing transportation and waiting times. 4. Quality at the source. Empowering employees to take responsibility for the quality of their work and to identify and resolve issues immediately. It prevents defects from being passed down the line and reduces the need for extensive rework. 5. Standardized work. Establishing clear and consistent procedures for each task to reduce variability, improve predictability, and facilitate continuous improvement efforts. 6. Just-in-time procurement. Building strong relationships with fewer reliable suppliers who can deliver high-quality materials frequently and in small quantities, precisely when needed. 7. Visual management. Using visual cues and tools to make the status of the production system transparent, allowing for quick identification of problems and deviations from standards. 8. Continuous improvement, Kaizen. Warehouse management and optimization. Often perceived as a mere storage facility, the warehouse is a critical hub within the modern supply chain. It is a dynamic interface between procurement, production, and distribution, significantly impacting efficiency, cost-effectiveness, and customer satisfaction. Effective warehouse management transcends simply storing goods. It encompasses a complex interplay of processes, technologies, and human capital to ensure the seamless flow of materials and information. Often perceived as a mere storage facility, the warehouse is a critical hub within the modern supply chain. It is a dynamic interface between procurement, production, and distribution, significantly impacting efficiency, cost-effectiveness, and customer satisfaction. Effective warehouse management transcends simply storing goods. It encompasses a complex interplay of processes, technologies, and human capital to ensure the seamless flow of materials and information. The process. The typical flow of goods and information within a warehouse can be broadly categorized into the following stages. 1. Receiving. This involves accepting incoming goods, verifying them against purchase orders, and conducting initial quality checks. Efficient receiving processes are crucial for ensuring accurate inventory records and preventing delays. 2. Put away. Once received, goods are moved to their designated storage locations within the warehouse. Effective put-away strategies aim to optimize space utilization and facilitate efficient retrieval of items. It often involves considering factors like product characteristics, frequency of access, and storage equipment. 4. Order picking. This process involves retrieving specific items from storage to fulfill customer orders or supply production lines. Order picking is often the most labor-intensive and time-consuming warehouse activity, making its optimization a key focus. Various strategies, including zone, wave, and batch picking, can be implemented. 5. Packing and shipping. Once picked, items are packed securely and labeled for shipment. This stage involves verifying order accuracy, selecting appropriate packaging materials, and generating shipping documents. Efficient packing and shipping processes ensure timely and accurate delivery to the end customer. 6. Inventory management. Maintaining accurate inventory records is paramount throughout these stages. It involves tracking stock levels, locations, and movements to prevent stockouts, reduce excess inventory, and support informed decision-making. Warehousing, distribution, and last-mile delivery challenges. Warehousing challenges. Beyond the internal optimization discussed earlier, warehouses face challenges related to their strategic location and integration within the broader distribution network. Location optimization. Demand volatility. Scalability. Sustainability. Distribution challenges. Transportation costs. Rising fuel prices, driver shortages, and the complexity of transportation networks significantly impact distribution costs. Route optimization. Inventory visibility across the network. Regulatory compliance. Last-mile delivery challenges. The concluding segment of the delivery process, extending from the distribution center to the end customer, frequently presents the most considerable challenges. Significant expenditures. Delivery density. Urban congestion. Customer expectations. Returns management. Logistics and distribution. Efficient operations management extends beyond the factory floor and warehouse walls, encompassing essential logistics and distribution activities. Purpose and objective. Articulate the critical role of logistics and distribution in achieving operational excellence. Outline the key processes involved in the logistics and distribution function. Analyze different transportation planning methodologies and their impact on efficiency. Discuss the complexities and considerations of global logistics operations. Apply practical examples to illustrate core concepts in logistics and distribution. The process. The logistics and distribution process typically involves interconnected activities to ensure the right products are delivered to the right place, at the right time, and in the proper condition. A simplified process flow includes 1. Demand forecasting and planning, predicting future customer demand to anticipate inventory and distribution needs. 2. Inventory management, determining optimal inventory levels at various points in the supply chain to balance costs and service levels, covered in detail in previous sections. 3. Order processing, receiving, validating, and initiating the fulfillment of customer orders. 4. Warehousing and storage, managing the storage of raw materials, work in progress, and finished goods. It includes warehouse layout, material handling, and inventory control. 5. Transportation planning, selecting the most appropriate transportation modes and routes to move goods efficiently and cost-effectively. 6. Transportation execution, managing the physical movement of goods, including loading, shipping, and tracking. 7. Delivery and customer service, ensuring timely and accurate delivery to the final destination and providing post-delivery support. 8. Reverse logistics, managing the flow of goods returning to the organization for reasons such as returns, repairs, or recycling. Transportation planning. It encompasses various activities, including route optimization, shipment consolidation, carrier selection, and the implementation of transportation management systems. Effective transportation planning seeks to minimize transportation costs, reduce transit times, enhance delivery reliability, and improve overall supply chain visibility. Key considerations in transportation planning include the nature of the goods, distance, urgency, cost constraints, and regulatory requirements. Transportation modes and network design. Selecting the appropriate transportation mode is a critical aspect of logistics. Common modes include: First, road. Trucking offers flexibility and door-to-door service, making it suitable for a variety of goods and distances. Second, rail. Cost-effective for long-haul transportation of bulk goods and large volumes. Third, air. Fastest mode for urgent shipments and high-value, low-weight goods. Fourth, water. Sea and inland waterways economical for large volumes and long distances, particularly for international trade. Fifth, pipeline. Used for transporting liquids and gases. Network design refers to the strategic layout and configuration of transportation routes, hubs, and distribution centers, encompassing the planning and implementation of these elements. Decisions regarding network design involve factors such as the location of suppliers and customers, the volume of goods being moved, and the desired level of responsiveness. Different network designs, such as direct shipping, hub and spoke, and cross-docking, offer varying trade-offs between cost, speed, and complexity. Global logistics. Global logistics deals with the complexities of managing the flow of goods across international borders. It introduces a range of additional challenges compared to domestic logistics, including extended lead times. International shipping typically involves prolonged transit durations and potential delays due to customs processes and geographical distances. Increased costs, tariffs, duties, international transportation fees, and other logistics expenses. Regulatory and cultural differences. Navigating various customs regulations, trade agreements, and cultural practices across countries is essential. Currency exchange rate risk. Fluctuations in exchange rates can impact the cost of goods and transportation. Complex documentation. International shipments require extensive documentation, including invoices, packing lists, customs declarations, and certificates of origin. Security concerns. Ensuring the security of goods throughout the international supply chain is paramount. Effective global logistics requires a deep understanding of international trade regulations, customs procedures, and the capabilities of international transportation providers. Sustainable inventory practices. The sheer volume of raw materials, components, and finished goods held in global supply chains has significant environmental and social implications, ranging from resource depletion and energy consumption to waste generation and concerns about ethical sourcing. Purpose and objective. By exploring this topic, you should. It incorporates lean inventory management principles, the principles of the circular economy, and ethical sourcing practices. Explore various strategies and techniques for implementing sustainable inventory practices. Discuss practical approaches to reduce waste, optimize resource use, and promote ethical considerations throughout the inventory lifecycle. Analyze the benefits of adopting sustainable inventory practices. Beyond environmental and social responsibility, explore the potential for cost savings, enhanced brand reputation, and improved operational efficiency. Remember, the more you learn, the more you earn. Never stop learning. Life never stops teaching.